when we were doing the reverse, we had like tan, negative 7 pi over 6, and we gave an answer. We agree? Now we're going to be given an answer, and we have to find the degrees that fit. So the first thing I have to do always is get it, the sine, the cos, the tan, whatever it may be, by itself. So I have to grab a marker. That's what I have. So I have 2 sine theta equals 1, and then I'm going to divide by 2. So I get sine theta equals a half. Now the thing is, on your unit circle, you will always have, two solutions, 2 degrees or 2 radian measures that answer to that, correct? Because that's sine positive, and sine is positive in quadrants 1 and 2, so I'm going to get 2 solutions just that are principal angles. If it was sine equals negative a half, I'd get 2 solutions that are principal angles, correct? So no matter what, I'm going to get 2 solutions somewhere on the unit circle, even if they just restrict my domain between 0 and 2 pi or 0 and 360. Okay? So I'm going to look for where sine equals a half. Sine equals a half at 30-degree reference angles. So I don't, like, here's a domain. I'm like, not today. I just look and say, oh, it's degrees. That's all I care about right now. It's degrees. So I'm going to get my answers in degrees. So I go theta equals, and on my unit circle, where is it at?
30 degrees.
Y is a half at 30 degrees and 150. Now let's pretend degrees. Now let's pretend that it's not off our unit circle or we don't spot the half. We can still get reference angles. Remember, how did we get reference angles? What did we always do? We did it when we had like points and coordinates, yeah.
First sine.
Yes. So we'd inverse sine of the what always?
Positive.
The positive, because then it lands us in quadrant 1, whether it's negative or positive, gives us a reference angle. So if I want reference theta, I'm going to do sine neg 1 of a half in degree mode. So everyone should type that in, just for practice. Make sure you're in degree mode, because this is in degree mode, right? And sometimes people will do these completely in degrees, and then the very last step convert it to radians if the thing's in radians. It doesn't matter if you do that. If they want an answer in radians, you do the whole thing in degrees and then convert at the end. They don't care. It's the same thing as if you did, like, you solved a physics question and you got it all in meters, let's say. You could convert to kilometers at the very end. Yeah. Yeah. So this would get us 30. And then we know where it actually exists by cast rule, right? It's sine positive, so I know it's here and here. So it's 30 and 150. So I can use just the reference angle and cast rule, C-A-S-T, to find out where the angles are too without the unit circle, right? And you have to do it this way if it doesn't fall on one of those exact values. Like say I gave you 0.6792 as your answer. Well, that's not one of the ones on the unit circle. So I would have to do reference angle cast rule. So there's 2 ways I could do this. This way only works, the first way only works if it's actually an exact value on the unit circle. The second way always works, no matter where it is. Okay? So once I get my principal angles, then and only then do I actually go to the domain. Okay, they want it between 0 and 360. Sweet, that's actually what they made me find. That's what I found. Principal angles are between 0 and 360. Now you also have to watch yourself. Sometimes they have equal signs, and sometimes they do not. We agree? If they have equal signs, you could give that solution. If they don't, you wouldn't. And on my niece's homework, on her first one, I put the 2 pi on, and then we got the solutions back, and we only got 105, because the 2 pi was a rounded bracket. That's stupid me. And if it's a round bracket, it means not equal to, and I wasn't allowed to give that solution. But I did. All right. So, boom, we're done. These are the only 2 that fall between 0 and 360. Now, wouldn't it be nice if it was always 0 and 360? But it's not going to be. But is it still overwhelming if it's not 0 and 360? It shouldn't be. It shouldn't be. You just find your coterminals. Call it a day, right? You don't need to sketch it and make it land on it or anything like that. Coterminals. Okay. This one. Cotangent. First thing I need to do is get it cotan by itself. So I do cotan theta equals 1/4. I have no idea where that is on my unit circle because it's not. So I go second cotan of a quarter. Oh, crud. No, I don't. I don't have a second cotan button. What do I have? Yeah.
You have a 10.
I have a tan button. So I go tan theta equals a quarter, obviously. No. What do I have to do? Yeah, tan theta equals 4/1. Because I can flip answers, but I can't flip angles, right? And tangent is just the reciprocal trig identity of cotan, so I can flip it. Now, is it on my unit circle? No. So I have to do the 2 steps. I have to do the reference angle and cast rule, right? Every single time. And I know it's in degrees. I don't care what the restricted domain is. I just know it's in degrees, so I'm going to get my answers in degrees. So I'm going to get my reference theta, which is tan neg 1 of 4. And what's my reference theta equal? Some decimal of some sort. Yeah, so we'll go to the nearest tenth, which would make it be 76.0. Remember, do we want to actually round though? Is this the answer? No, so am I allowed to do what I just did? No, it's bad news bears. So I would actually go. Like it keeps going, right? So I'm not allowed to round until the answer. Yeah.
I get 75 and then continuing on.
That is a 5. I have no idea what you're talking about. It's been a 5 the whole time. Totally clear that it's a 5. Perfect 5. Great 5. Please don't do that on a test. Erase it and put a 5. Don't do as I say, not as I do. Okay. Cool. So we got the reference angle. What's our next step? And then we can get answers and we can move on. Yep.
Because it's 180, see if you can get another one that's less than 180.
We need to first do what?
Draw it.
Try. Wow, that's a straight line. Pretend that's straight. Cast. C-A-S-T. What quadrants is it in? We go back to the original. It's cotan of positive or tan of positive. So where is it positive? Okay. Yes. You should have said 1. You gave me 3. Yes. It's perfect. So I can actually draw it somewhat correctly because it's 75 for reference angle. Remember your reference angles from your x-axis. So this here is 75.9637 degrees, right? So my first answer would be just that, 75.963, wow, 637. And then this one would be, what do I do? How do I get this bad boy? 180 plus it. So I get 55.9637 degrees. Bless you. So now I have my 2 principal angles. We agree? Once I get my 2 principal angles, then I go to my restricted domain and see. Sometimes it's restricted to smaller than 0 to 360. Sometimes it's restricted to larger. Sometimes it's negative 360 to 0, and there is no 0 to 360. Both your solutions actually are solution. Okay? In this case, it's 0 to 180. So which one fits? Yeah, and they do this when it's a numeric response, because you get one answer. So if we say to the nearest whole number, which they have to give you some sort of rounding rule, it would be 76 degrees. The other one's outside the domain. It's too big. Ooh. Ooh. There's a squared. There's a cosecant. There's so many great things. It's so exciting. Quite riveting, really. So if we have to solve a trig, we have to get it, the trig ratio by itself, right? So we have 4 cosecant squared theta equals 25. Divide by 4. How do I get cosecant by itself with the cosecant squared? If I don't face you, you have to speak. Yes?
You square root.
Yes. And when you square root, you must do what? Plus or minus, people. You're going to get 4 answers. I'm going to star this. you're someone who's going to miss, this one's done most four because people don't put the plus or minus sign. You're actually going to get four solutions. It's going to be in every quadrant, right? 2 positive solutions, 2 negative solutions. If you forget the plus or minus sign, you will get 2 solutions. They will be there. You'll pick it. You'll think you're positive, or you won't, because sometimes you don't believe in yourself. And you shouldn't at that point. And move on. Okay? So plus or minus. This one we can actually just do both of them because they're both perfect squares. So we get plus or minus 5 over 2, which is a great solution. And then I go to my reference angle, second cosecant 5 over 2. And then I go, darn it, I don't have cosecant button. So what do I have to do? Sine. Sine theta equals plus or minus 2 over 5 because it's a reciprocal trig identity. And if I want the reference theta, I take the what of it? Yeah, the inverse and positive so that it lands in quadrant 1 whether I have an answer there or not. So I could do that, or I could say, hey, my domain's in what? Radians. So I could go put my mode in radians and get that instead. It doesn't matter which way you do it. It does matter that in the end you do have radian answers though, right? So I get my reference angle and then I use my cast rule. Well, it's in every single one of them. So this one would be 0.41. How do I get this one? These are all 0.41. How do I get quadrant 2? Yeah.
Pi minus
That decimal?
e.
So I get 2.7300. The third one, I'm going to do pi plus the decimal. So I get 3.553. And how do I get it in quadrant 4? 2 pi minus. Five decimal 8716 degrees. What am I doing? It's an addiction. Ignore that. Also, don't do that on the test. I'm going to show you. Yeah. I'm going to have people following what I do and be like, well, you did it. Okay, then I go to my domain and I say, oh, 0 to 2 pi, and then I throw a happy dance because, man, that's easy. I already found them. We agree? Could you have done it in degrees, got all 4 of them in degrees, then just converted to radians in the end? Yes. The only catch is you can't round until the very end, right? So you have to take that decimal that is not a nice decimal and then convert it by multiplying by pi over 180. All right. So our theta equals, that's the variable that's used, theta equals, and remember when it says solve, this one says find, it should say solve. When it says solve, you're ultimately in the end, doesn't matter what math course you're in or anything. If it says solve, you have variable equals number. That's what solve means, right? Tell me what the variable equals. Well, this one is theta. So theta equals, and we'll say to the nearest 10, 2.7. Why I started there, I don't know. 0.4, 3.6, 5.9. I was listing them in order, but I was a rebel today, I guess, and did not. So you guys did this last year. You would have solved these last year exactly the same. Then you also did, we'll look at these ones. Cos theta equals 0. Where does cos theta equal 0? Okay.
0 and 180.
It's where x equals 0.
That's backwards. That's 90 and 270.
Yeah.
I mean.
90 degrees and 270. Do I have to show any work? No, it's directly off the unit circle. What about tan theta being undefined? Yeah.
90 and 270.
Why?
Because we're dividing by 0.
Because you're dividing by 0. Tan is sine divided by cos, or y divided by x. So I need to look for any y, I don't really care what it is, but my x needs to be 0. We agree, in order to get undefined? So I'm looking where x equals 0, which is the exact same spot where cos is 0. So it's the same answer. Okay? Can you grab on a separate sheet of paper? We're going to do something fun.
You can keep a straight face saying that.
It's fun. It's fun. It's fun. It's fun. What if I give you this? And it would say solve. When it says solve, ultimately I need trig ratio equals something, correct? So what am I going to have to get together first?
The x's.
Yeah, those cotans, right? So I have a 3 cotan x and a 4 cotan x. I need to move them together just like as if they were 3x and 4x, right? So I'm going to subtract the 3 cotan x over. So I get 1 equals 2 plus cotan x. And then what am I going to do? Yeah, subtract. Now I have cotan x equals -1. You try and solve. Where's cotan or tan equal to 1s or -1s at? Oh, the cereal landed again. Cheerios down. Oh, there's more falling.
Oh,
They're
wow.
falling more. Where is cotan or tan equal to 1 or -1? Where x and y are the same, right? Because you're doing x divided by y for cotan. And x divided by y is the same at all the 45s, because the 45s are √2 over √2, right? X's and y's. So cotan is +1 in quadrant 3 and 1, because it follows cast rule, and it follows the tan's cast rule. So cotan equals +1 here and here, but they don't want +1. They want cotan equaling -1, which is here and here. So it's going to be at 135 and 315. Now, if you forget how to do it, you could go, this is over 1, so you could go tan x equals -1. Then you could do x equals tan -1 of 1. And it'll give you 45. And then you use cast rule. It's the same thing, right? It doesn't matter how you go about it. This could get you your reference. Now, those are both good solutions because it's from -180 to 360. Now, what I make people think about it is this is -180 to 0, technically. And then it's 0 to 360. But we're solving for x in here. So we're going from -180, and then there's a 0 in here, and then there's a 360 over here, correct? But we can think of it that way and try and picture it and stuff, or we can just subtract 2 pi's and see which one fits. Or subtract 2 pi's, subtract 360. So I have 135 degrees, subtract 360, and I get -2, 25. Does that fit? No, too big. Out. And then I go 315, it's going to write 225, that's why I had 3 so bad, minus 360, and I get -45. Does that fit?
Yep.
Yes. So my solutions are not theta equals, because if I look up here, the variable is x, right? My solutions are x equals -45 degrees, 135 degrees, and 315 degrees. So we learned this all last year, right? We also learned this last year. More fun. Solve. Two cos squared x, or 2 cos squared, yeah, we'll say x. Plus 3 cos, or not plus, minus, I don't want to say plus. Minus 3 cos x equals -1. And I'm going to say from 0 to 360. Remember, when you have a squared, the very first thing you can do is write that as like let m equal cos x if you want to. You can go like let m equal cos x. And then you have 2m squared minus 3m equals -1. And then we're literally back to grade 11. When I have a squared, what do I always have to do to solve it? That's true. When I have a squared with a quadratic, I did not ask that question clearly. When I have a squared with a quadratic, I always have to do what? Make one side equal to 0. So I'm going to add the 1. 2m squared minus 3m plus 1 equals 0. And then I have to do decomp. So I say what times what equals the outside 2. So we're back to grade 10. So we have grade 11 and grade 10 in this. That's why grade 12 is a little bit more difficult, because every single question involves grade 10 and 11 math. It's not just your grade 12 math. So what times what equals the outside? So 2. And what plus what equals the middle? -3. And what do we get? Yes.
First assignment.
No, you would have signed it both opposite, so it would have still been confusing. One said -2, -1, one said -1, -2. That was the issue. But both were correct.
It's a negative.
It is. All right. So we have to replace our middle term. So we get 2m squared minus 2m minus 1m plus 1 equals 0. Then group. Put a plus sign in between your brackets. So I take out a 2m, and I'm left with m minus 1. Take out a minus 1, left with m minus 1. And then I say, what can I take out of the two terms? This one and this one. An m minus 1. And what am I left over with? 2m minus 1. This is all grade 11, grade 10 and grade 11. In grade 11, we were taught when set equal to 0, I can now take both of them, separate them, and set them equal to 0. Still doing grade 11. So we get m minus 1 equals 0. 2m minus 1 equals 0. This one is m equals 1. And this one is m equals 1/2. And then what do I have to do? Go back to grade 12. And replace the m's with cos x. So I have cos x equals 1. And cos x equals 1/2. So I am literally back to doing exactly what we just did. I just now have to do 2 of them to solve this question. Right? So I look and I say, okay, the domain is in degrees. This is no harder than the previous one. The hard part of this is doing the grade 11 math. That's the hard part, right? It's the same as what we just did. The hard part is doing the grade 11 math. Then we're back to what we just learned. So where does cos x equal 1? Where does x equal 1?
0.
And that's it. And 360. Okay? That's our principal angles. Once I have my solution, I then say, okay, the variable's x equals, and now I go to my domain and see what actually works. So I have 0, not inclusive, 360 inclusive. So which is my solution? 360. And then this one is where x equals a half, where cos is positive in 4 and 1. It's a half at 60-degree reference angles. So this one is 60, this one is 300. Then I go to my domain and I say, okay, my domain is 0 to 360. Sweet, it's the unit circle, right? In its true form, it's principal angles. So it's both of those. So adding the squared right now, am I actually adding any grade 12 skills? No. Adding the squared creates no grade 12 skills. Adding the squared makes you do grade 11 skills, and then you get 2 ways to do grade 12 skills, right? That's all it does. I'm not adding any grade 12 skills when I put a squared on here, because I immediately replace it with m, and now I'm just doing grade 11. And often they'll write the solutions together in order, so they'll go 60, 300, 360. And most of you did this last year, so you already this is actually know new skills. Unless I throw a cotan or like a secant or a cosecant, because those are new.
I'm still familiar.
Yes. Not botched, right?
Oh, I don't know about that.
Okay, so I want you to do page 211. Numbers 3, 5, BDF, and then we have to do the squared ones, which is 7, BCD. And we're done chapter 4. So we're done chapter 11, chapter 1, chapter 3, and chapter 4 out of 11. So 4